NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we'll solve a division of fractions problem by following the exact algorithm. First, convert division into multiplication by the reciprocal, then multiply the numerators and the denominators, and finally simplify. We'll also apply it to the example, 3/4 divided by 2/5. Here is the general case. We start with a over b divided by c over d. To divide, we keep the first fraction the same and multiply by the reciprocal of the second fraction, which flips c over d into d over c. Now we multiply straight across, numerator times numerator and denominator times denominator. Now, let's follow the exact same steps on the example. We want 3/4 divided by 2/5. Keep the first fraction, change division to multiplication, and flip the second fraction. Multiply numerators and denominators, 3 times 5 over 4 times 2. Now compute. 3 times 5 is 15, and 4 times 2 is 8. So the result is 15 over 8. This fraction is already in simplest form. Let's box our final answer. To summarize the rule and some quick special cases. General rule, a over b divided by c over d equals ad over bc. If the denominator of the second fraction is 1, then a over c divided by 1 over d equals ad over c. If the numerator of the second fraction is 1, then a over b divided by c over 1 equals a over bc. Example, we will divide algebraic fractions by following 4 steps. 1. Rewrite division as multiplication by the reciprocal. 2. Factor all polynomials. 3. Cancel common factors. And 4. Simplify coefficients and variables to get the final result. After that, we will summarize and offer a quick challenge. Rule: dividing fractions by multiplying by the reciprocal. We replace division by the reciprocal of the second fraction. Factorization of polynomials. We factor each numerator and denominator completely. For the first numerator, 4x squared minus 25. Y squared is a difference of squares. For the first denominator, factor out xy. For the second numerator, keep 9x squared y squared as it is. For the second denominator, factor out 3x. Cancel common factors across numerators and denominators. We can cancel the factor 2x minus 5y, and also the factor 2x plus 5y. After canceling these, we simplify what remains. Simplify coefficients and variables. 9 over 3 is 3, x squared divided by x is x, and y squared divided by y is y. Multiply the remaining parts to get the final expression. Therefore, the simplified result is 3y. Quick challenge. Try a similar. Step 1. Factor every polynomial. We use the difference of squares for m squared minus 9. We also factor the trinomial m squared plus 5m plus 6. And we remember that 3 minus m is the negative of m minus 3. Step 2. Change division into multiplication by the reciprocal. We multiply by the reciprocal of the second fraction. Step 3. Cancel common factors. The factor m plus 3 cancels, m plus 2 cancels, and m minus 3 cancels against the negative sign. We are left with 1 over negative 1, which simplifies to negative 1. Now, let's do a second example. We'll show the problem in bold orange again. Step 1 again is factoring. Factor y squared plus 5, y plus 4 into y plus 1 times y plus 4. And factor y squared minus 1 using difference of squares. Step 2, change division to minus 1 using difference of squares. Step 2, change division to multiplication by the reciprocal. Multiply by 1 over y plus 5. Step 3, cancel the common factor y plus 1. And write the simplified result. Finally, present the answer. Quick summary. We factored each polynomial, changed division to multiplication by the reciprocal, canceled common factors. In this video, we will solve a rational expression division problem step by step, and we will follow a clear visual structure for each rule we use. The word example appears. First, imagine we used a high-accuracy optical character recognition engine to read the formulas. We would extract the problem as left parenthesis, x squared minus 49 over 2x squared minus 3x minus 5, right parenthesis, divided by left parenthesis, x squared minus x minus 42 over x squared plus 7x plus 6, right parenthesis. Quick challenge. Before we start, can you predict our first algebra move for dividing rational expressions? Step 1. We rewrite division of fractions as multiplication by the reciprocal. That is, keep the first fraction, change the division to multiplication, and flip the second fraction. We use the difference of squares for x squared minus 49 and standard trinomial factoring for the quadratics. Step 3. Cancel the common factors that appear in both a numerator and a denominator. Here, x minus 7 cancels, x plus 1 cancels, and x plus 6 cancels. Step 4. State the domain restrictions. Any factor that appeared in a denominator before cancellation cannot be 0. That means x cannot equal 7, -1, -6, or 5 halves. Our simplified result is left parenthesis, x plus 7 over 2x minus 5, right parenthesis. Quick challenge. If the second denominator were x squared plus 6x plus 5 instead, how would the cancellation change? Take a moment to think before you answer. Summary. We reviewed. Rewrite division as multiplication, factor everything, cancel common factors, and state restrictions. We solved one complete example and previewed how small changes affect cancellation. Keep practicing with different trinomials and next learn partial fractions or complex rational expressions. Here is our example. Step 1. Division of fractions equals multiplication by the reciprocal. Now we flip the second fraction and multiply. Step 2. Factored the quadratic in the numerator. We look for two numbers that multiply to 10 and add to 11. That is 1 and 10. Step 3. Cancel the common factor x plus 1. We have x plus 1 in the denominator of the first fraction and in the numerator of the second fraction. After canceling, we simplify the product. Very important. Domain restrictions. From the original expression, denominators cannot be 0. That gives x not equal to -1, -10, and -4. Even though x plus 1 canceled, it still restricts the domain. First, we display the word example, then the problem in bold orange latex. Now we will follow the same algorithm and step order from the image. Rewrite division as multiplication by the reciprocal. We use the division of fractions rule. Thinking phase quick challenge. Which parts will change in the next step? Factor each quadratic. We apply factoring formulas, including difference of squares and simple trinomials. Sparkles note, we highlight the newly factored pieces in orange. Play button step 3, cancel common factors. We cancel identical factors appearing in numerator and denominator. Finally, we present the simplified result in green, enclosed by the words confetti. According to the instructions, we first display the word example, and then the problem statement in bold orange latex. Step 1. Use the rule fraction division equals multiplication by the reciprocal. We rewrite the division sign as multiply and invert the second fraction. Quick challenge. Can you predict the next step before it appears? We will factor all quadratics. Step 2. Factor all polynomials completely. Quick challenge. Which factors cancel? Take a moment to spot common factors in numerator and denominator. Step 3. Cancel common factors across numerator and denominator. Great job! We follow the exact structure. Rewrite, factor, cancel, and we obtained 1/2. Summary time. We will recap key ideas, highlight solved steps, encourage practice, and suggest a next topic. For completeness, here are the logs and metadata for this. We display the word example, then the problem in bold orange. Step 1. Division of fractions equals multiplication by the reciprocal. We replace division with multiplication and flip the second fraction. Now, we show the rule box. And here is the rewritten expression. Step 2. Factor the quadratic x squared plus 11x plus 10 into x plus 1 times x plus 10. Here is the factoring rule. And here is the factored expression with changes highlighted. Step 3. Cancel the common x plus 1 factor from numerator and denominator. Here is the simplification rule. And here is the simplified expression. Final answer for example 1. Now we present the next example and its problem in bold orange. Step 1. Rewrite division as multiplication by the reciprocal. Show the rule, and show the rewritten expression, highlighting the change. Step 2. Factor the denominators and numerators where possible. We use x squared minus 4 equals x minus 2 times x plus 2, and x squared minus 1 equals x minus 1 times x plus 1. Show the factoring rules, and show the fully factored expression with changes highlighted. Step 3. Cancel the common factors x plus 1 and x minus 2. Show the simplification rule. Then show the simplified result. Final answer for example 2. Here, in this lesson, we will divide rational expressions step by step, following the exact algorithm. Factor, simplify inside each fraction, change division to multiplication by the reciprocal, cancel common factors, and simplify. Problem 1. We start from the given expression. Step 1. Factor all polynomials. Step 2. Simplify each fraction by canceling equal factors. Step 3. Change division to multiplication by the reciprocal. Step 4. Cancel common factors across the multiplication. Step 5. Simplify the remaining expression. Finally, we will note domain restrictions for the original expression. Problem 2. We start from the given expression. Step 1. Factor all polynomials. Step 2. Simplify each fraction by canceling equal factors. Step 3. Change division to multiplication by the reciprocal. Step 4. Cancel common factors across the multiplication. Finally, simplify to the result. We will also note the domain restrictions of the original expression. Summary. We followed the exact algorithm. Factor each polynomial, simplify inside each fraction, change division to multiplication by the reciprocal, cancel common factors, and simplify. Always state domain restrictions from the original denominators to complete your answer. Welcome! In this lesson, we'll learn how to divide rational expressions using factorization. The strategy is simple. Step 1. Rewrite the division as multiplication by the reciprocal. Step 2. Factor every numerator and every denominator. Step 3. Cancel common factors. And Step 4. Multiply what's left. Let's build intuition and then practice with examples. Say it with me. A over b divided by c over d equals a over b times d over c. We flip the second fraction. Then we factor and cancel. Example 1. Simplify the following by division. We start with the original expression. First, write it as multiplication by the reciprocal. Now, factor everything you can. Difference of squares, common factors of a, and grouping in the denominators. Cancel matching factors. We cancel 2x minus 3a on top and bottom. We cancel b minus a on top and bottom. We simplify a cubed divided by a to get a squared. Multiply the remaining factors for the final simplified form. Example 2. Simplify by division. Here is our expression. Rewrite division as multiplication by the reciprocal. Now factor x squared minus 4 is x minus 2 times x plus 2. A squared minus b squared is a minus b times a plus b. Cancel a plus b, cancel x plus 2. We are left with x minus 2 over a minus b. Example 3. Another division problem. Here is our expression. Change division to multiplication by the reciprocal. Factor x squared minus 2x minus 8 as x minus 4 times x plus 2. And again a squared minus b squared as a minus b times a plus b. Cancel a plus b, cancel x plus 2. We obtain cancel x plus 2. We obtain x minus 4 over a minus b. To summarize, when dividing rational expressions, flip the second fraction, factor thoroughly, cancel any common factors, and then multiply what remains. These techniques come straight from factoring and the laws of exponents. Practice a mix of difference of squares and trinomial factorizations to build speed and confidence. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.